Today's video is going to cover lesson 2.3. This is the final relations lesson, and specifically we're going to look at the independent and the dependent variables and how to identify them in different relationships. This is a relationship that you are most definitely familiar with, as it is one that you and your parents probably fight about all the time. Mom, I'm super independent, let me have my own freedom, and she's reminding you that you're not very independent, that she pays for your phone bill, your food, your clothes. But we're going to look at this in a little bit different context. So today's goal is to identify the independent and the dependent variables within a relationship. And they look different, and sometimes they're easy to identify, sometimes they're a little bit more challenging to identify. So our goal is to be able to identify them in pretty much any relationship. Just a couple key terms today. Obviously, independent and dependent. So I'm going to go ahead and kind of
Coaches meeting start.
I'm going to go ahead and come back to this slide, and I'm going to kind of give you a representation of what the independent and the dependent variable and how they relate. So the independent variable is independent from anything else. It stands alone. It does not depend on anything. And then the dependent variable depends, as that is the core part of the word, dependent, depends on something. So an easy way of thinking about the relationship between the two is the independent variable influences, almost spelled it wrong, influences change in the dependent variable. So if the independent variable changes, the dependent variable changes. Sometimes this change is significant, sometimes this change isn't significant, but the main part is that the dependent variable depends on the independent variable, not the other way around. So this is one of several different ways visually that you can represent the relationship. So let's go back to our key terms. And so we've got these four different kind of definitions for independent and dependent. So the independent variable is represented by x. In math, you always use x, or when x is used, it's representing the independent variable, and the dependent variable obviously is represented by y. So on the x, on a coordinate plane, if you see something that's being measured, two things that are being measured, the thing that's being measured on x is the dependent variable, and the thing that's being measured on y is the thing that's being measured on x is the independent variable, and the thing that's being measured on y is the dependent variable. Oftentimes you'll see time for x, and you'll see something like distance or height for y, because those quantities are based on the time. The independent variable is defined with, so we learned about this in the last lesson, it's defined with the domain. So the domain defines the independent variable, or which independent values are within that construct. And the dependent variable obviously is defined by the range. And now the value type. Well, the value type for the independent variable is the input. When you put something in, you're inputting it into x, which is your independent variable. And then you get something out. It's the output of y. So the output depends on what the input is. And then the last definition is the nature of the variables themselves. And we've kind of already hit on this, and I keep talking about it. The idea is very, very intuitive. So sometimes it's very, very challenging to explain because it's very natural to us. But the nature of the independent variable is it's a value that can be chosen freely. And we'll see this more in the next lesson when we start getting into functions. But this is a value that you get to choose, or you get to control. Like in a science experiment, the independent variable is the variable that you get to manipulate. It's a value that you can choose. The dependent variable you do not choose. It is like a value that you observe or you measure based on what you chose for the independent variable. So this is a value that depends on another value. Obviously, the independent. So these are 4 different ways of thinking about the two. So let's go ahead and get into some examples today. Example number 1. The Hancock Math Club is hosting a puzzle hunt. The number of teams depends on how many participants there are. Then it gives us T equals the number of teams and P equals the number of participants. Which of the variables is independent, which is dependent? So these are the two variables. We've got number of teams represented by T, and we've got number of participants represented by P. So let's go ahead and read it one more time, and we're going to look for like a key word or something to give away the relationship. But I will say this: when trying to decide the independent and the dependent variable, what they are, the best way to approach this is to figure out the dependent first. I'm going to abbreviate it. Oftentimes it's easier to figure out what depends on something else before it is to figure out the independent part. So the Hancock Math Club is hosting a puzzle hunt. The number of teams depends, so here's a key word right here, on how many participants there are. Well, if the number of teams depends on how many participants there are, then we know that the number of teams is our independent variable. I'm sorry. The number of teams is our why am I getting them confused? The number of teams is our dependent variable because it depends on how many participants there are. So this is our y, and this is our x. So if there's 5, so if you think about the nature of the relationship, the number of participants determines how many teams there are. So if there is 10 participants and they're forming teams of 5, then there's going to be 2 teams. Well, if there's, let's say, 20 participants and they're forming teams of 5, how many teams are there going to be? There's going to be 4 teams. So that's the nature of this relationship. Let's go ahead and get into another example. So here we have the identify the independent and the dependent variables in each relationship, or each relation. So we're trying to figure out, of these 3 relations, which one's the independent, which one's the dependent. And I'm going to go ahead and do the same exact thing I did last. I always do that. It's like the 4th time today. I'm going to use x and y for dependent and independent because they're just simpler to write. So I'm going to go ahead and read the 2, and while I read them, think about which one you think depends on the other. So the amount of money that you make, or the number of hours you work. Which of these depends on the other? Does the amount of money you make depend on how many hours you've worked, or does the number of hours you work depend on the amount of money you make? Well, for me and most people, you do not get paid until you work. So the amount of hours you work comes before you get paid. Well, if it comes before you get paid, that means that the amount of money you make depends on, this is dependent on the number of hours you work. If I'm working at Starbucks and I get paid $8 an hour, and I work 2 hours, I make $16. However, if I work 4 hours, then I make $32. So the number of hours is independent, does not depend on the money that I make. The money that I make is dependent here. So we're going to say this is y, and this is independent x. What about the second one? The amount of gas in your tank and the distance that you drive. If you said the distance you drive depends on the amount of gas in your tank, you are correct. The distance that you drive depends on how much gas you have in your tank. If you've got a full tank, you're going to go farther than somebody who has half a tank. I know firsthand that you don't get very far on a quarter of a tank. Why am I using yellow? It needs to be white. There we go. Last one. The length of your hair, the amount of time since your last haircut. If you said that the length of your hair depends on the amount of time since your last haircut, you were correct. If I get my hair cut on Monday and a week later I get it cut again, my hair is not going to be very long. If I get my hair cut on a Monday and then I get my hair cut a year later, my hair is going to be very long. So the amount of time is not dependent on my hair length. My hair length is dependent upon how much time since my last haircut. So this is our Y, and this is our X. One more example today. And this is a very easy, quick example, just kind of show you what I meant when I said choose freely. So in this equation right here, we're just going to select a couple values. We're going to choose a couple values for our input or our independent variable. So we get to kind of select these. So I'm going to select -3, I'm going to select 10, and I'm going to select 1. Now, we do not get to choose the output value. The output value is determined based on our input value after we simplify it. Oftentimes in equations, the independent variable will be on the same side as other numbers, or will be on the expression side, and the dependent variable will kind of stand alone. So if we put in -3, we've got 2 times -3 plus 1. This is our input. We're going to simplify to figure out what our output is. So we get -5. That is what Y is. So our output for when our input is -5 or -3 is -5. So we can go ahead and write that right here. And I'm not going to go over the last two, but I just kind of want you to see what the input and what the output and what the independent and what the dependent variables look like in algebra. Good luck on the homework.